here. What do you know about this line here? Yes, yes, what? Slope is 2/1. What else do we know?
Y-intercept.
Y-intercept is
0,
-5. Everybody with me? By the way, that's the second page here. So what do I plot first? Y-intercept. So that's 0, -5. And from there, where do I go? Say again?
Rise 2.
Yeah, go up to?
Run 1.
Run 1 forward, darling. And then I can do it again. Rise 2, run 1. Rise 2, run. I can do it until I go insane, but let me stop right there. How can I check that? Do it in a graphic calculator. No, stop. Yeah, so what point is this?
1, -3.
Yeah, 1, -3. So that means when I put a 1 into x, I better get a -3 out. Man, it's a rough day for talking for me. 2 times 1 is 2 minus 5 is -3. Yay! I mean, it's always nice to see that shit happen. We got to that point using the slope, not using the full equation, but everything worked together to get there, so it's got to work in the equation. Every point your line goes through must work in the equation. That's the connection between the equation and the visual. Kick ass. What do I do for number 2 first?
1.
Yeah, so add 2x, and I get -3y equals 2x plus 9. Is that right? And then, sorry, divide by -3. So then I get y equals -2/3 x minus 3. Is that all right? So what do I know about this? The slope is -2/3, and the y-intercept is 0, -3. So I start with the y-intercept, or whatever point I know. I just happen to know the y-intercept, so I start there. And where am I going to go from there? I could go down. Somebody, what's up with you guys? You all right? You're like, I want to watch a movie. I don't like talking to them. It's not a movie. Tell me what's going on.
Down 2.
Down 2, over 3, or I could do what? Up 2, back 3. And see, that's the same line. So that problem is done. And again, you could, if you want to take that point, plug a 3 in, you better get a -5 out. You can check that. All right. Thank you. Car. So pretty cool those. I mean, that needs to be sort of bread and butter. If it isn't quite there yet, it needs to be soon. Solve for y. I know the slope and the y-intercept. I can graph the whole line just with those 2 things. So this is kind of going the other way. This is going, all right, that's nice. If I give you an equation, you can graph it. What if I give you a graph? Can you equation it? Just to verbalize that now. Thank God I don't teach English. So what do I need to know? What are the 2 things I need to be able to write the equation of a line? Slope? Y-intercept, or just any point, because remember we got good old 1 minus y1, but up here, yeah, hell yeah, I'd rather know the y-intercept, because then the y piece would be just the what? Yeah, the y piece would be the b. That would kick so much ass. So on the first one, what would the value of b be? Yeah, since the y-intercept is 0, 2, b would be 2, and how do I figure out the slope? This one kind of sucks a little bit. I always try to give you problems that have like little points on them, so you know it's not just, you know, like, is that really crossing? But I mean, what 2 points does this definitely go through? Obviously 0, 2, but what else? 1, 0, yeah. So then how do I get there? I go
Down 2.
down 2?
2 over 1.
Yeah, down 2 over 1. How are we doing there? Is that all right? So what's the equation then? Y equals?
Equals next to 2x plus 2.
Bam. How's that? Is that all right? And just to check it, what should happen if I put a 1 in? What point is this?
1, 0.
So when you put a 1 in, negative 2 plus 2 is? Yay, thank the gods. Okay. Well, you guys try number 2 if you haven't done that yet. Not quite. So here's the, you can do this algebraically, thank God. If you solve this one for x, you can plug that in here. Yep. Because these two are supposed to be true at the same time. That's why it's an extra credit problem. So if you solve this for one of the letters, or you solve it for y, you can take this and put it in here. So really, think about it. What does it mean for 2 lines to intersect? Their equations must equal each other. So set these to equal each other. And when they meet, what must be true about their y's? They have to be the same, right? Therefore, you set these two equal to each other.
To get x.
To get x. I got you. All right, so here, what do we got? What's the b value going to be? 3. And then let's see, I'll definitely go through that point, and it looks like I go through a lot of points I can use. So what's the slope going to be?
1.
Yeah, because they will go up 1 over 1. That's too nice to believe. So what's the equation? X plus 3. Bang. So what should happen when I plug a negative 3 in? Negative 3 plus 3, 0. And sure enough, it goes to the point negative 3, 0. Yay. Okay. So there are ways to check these kind of problems. Do you notice how we're analyzing the same kind of ideas from different directions, which is, you got to be able to handle them all, but you should really understand an idea when we're doing it in multiple different ways, is every match it yourself. And here's a whole section all about stuff we already know, right? So let's see, have you guys had a chance to do these yet? If 2 lines are parallel, and the first line has a negative 2 slope, what's the slope of the other line? So the other line's got to have a negative 2 slope also. That's the idea of parallel. If 2 lines are perpendicular, and the slope of the first line is 2/5, the other line's got to have what slope? 5 over 2. So for parallel, it's completely the same. For perpendicular, it's totally opposite. And there are 2 main ideas of opposite. When I say opposite, I could mean different sign, or it could mean reciprocal, and we just do both. Make it totally opposite. 2 lines are perpendicular, and the slope of the first line is negative 3. The slope of the other line is going to be
1/3.
1/3. Change the sign, flip it. That's all you got to do for perpendicular. What do I got to do here to figure out if these are one of these things?
Rising to the form.
Parallel and perpendicular relate to what? Comparing the slopes. What's the quickest way to figure out the slopes of those things? Beautiful. Solve for y, peak x, which is slope intercept. So if I solve this one for y, let's do this one first. Let's see if you guys can handle this. Subtract the x, divide by 2. you don't trust me, you can do the one step I skipped. This one, do you guys notice everything's divisible by 3? So I'm going to start there. If I can see. All right. And now here's one little trick. I want to solve for y. I can skip a lot of steps by just adding the y, subtracting the 4. So see how the y and the 4 switch places. And the way I write y's and 4s, it looks like they already did. But these just switch places because I'm going to add the y, subtract the 4. So I get y is 2x minus 4. Are those parallel? Definitely not parallel. Are they perpendicular? Yes, because 2 is the negative reciprocal of negative 1/2. So perpendicular. Do they have to be one or the other? Do they have to be? What if this was negative 1/3? Is it the negative reciprocal of 2? No. Are they the same? No. So it would be neither in that case. In this case, it isn't neither, so let me not make it look like it is. Okay. Did you? Yeah, there you go. Same thing here, right? This one's kind of nice because this is already solved. If I do this one, add the x, divide by 2. I can't see anything. It's plus. Okay.
Neither.
Good, this is neither.
Yep.
They're not the same and they're not negative reciprocal. So the correct answer there is neither. It's pretty cool that. Then again, you don't have to meet at you can meet in all kinds of angles. To be perpendicular means you have to meet at 90 degrees. So of course there's a whole shitload of lines that don't stay parallel or meet at 90 degrees. They meet at some weird ass angle. So that's what these two did. Okay, I like it. Ooh, I like this one. All right. What does this tell me right there?
The same slope.
All right. So this tells me that my line has a same. I like it, John. It's got the same slope as this. So let me try this again. I said this earlier, but let me make it really in your face here. If the question says, find the equation of the line that stuff, what two things do I need? A point and a slope. All right. So how do I determine my slope? Eh? What do I know about my line? It is parallel to that one. So if only I knew that guy's slope, then I know mine. So I got to focus on figuring out his slope. The quickest way to do that is? Solve for what? If you want to know some line's slope, the quickest way to figure it out is to solve for y. Because then whatever number's in front of x is your slope. And again, this is another situation. See, I can just switch the y and the 1. Add the y, subtract the 1, so I get y equals 2x minus 1. So what's my slope?
Over 1. 2.
I like it.
Yeah.
And what's my point?
0.
You're all like, we're not sure, Jeff. I do have one sometimes. So what does that tell me that's beautiful?
4.
It tells me what b is, right? B is? Negative 3. So y equals mx plus b. So y equals
2x
2x
minus 3.
minus 3. Done. You guys see that? If I didn't have the y-intercept, what could I do? I would use this guy.
With another point.
No, just to put the point in. Right. If I know the y-intercept, I know b, so I use this guy. If I don't know the y-intercept, I don't know what b is, so I use this guy. So that's the last page in this. That's this page. We start off with an example just to show you that you don't have to know the y-intercept to use the idea of the slope. You can use any point that's on the line. So if I graph negative 1, negative 3, that's where I can start. And then what's the slope tell me to do from there?
Goes on to 5.
1, 2, 3, 4, 5. 1, 2, 3.
Yeah.
I like it. Kind of want to go further with that one. Let's go further with that one. Just before we get down to here. So watch this. My slope is 5/3. My point is right there, right? So if I use this guy, can I write the equation of this line? Y minus what?
Negative 3.
-3, that's the y piece. Equals the slope,
F over
5/3, times x minus
Negative 1.
-1. Alright, so then I get y plus 3 equals 5/3 times x plus 1. That's all I want to do with it. Then you could distribute the crap, right? But that's how, if I knew the y-intercept, that kicks ass, because then I know b, I can plug it in, I can be done with it. If I don't know the y-intercept, damn it. But I do have an equation. I can plug the x and the y piece, and then I can simplify it. So you would go a little further. I'm just out of room. Let's look at these problems. Try to do this one if you haven't done it yet. Notice what they say. So just to let you know, that means you don't have to solve for y in this case. No, it was just really a problem to keep people occupied while everybody else caught up. Yeah, but you did great. You got, well, you got part of it. You know, x is 1, you gotta know what y is. How do you know y is 0? Y is this, or this. You know what x is now. But how do you know it's 0 though? Plug it in. Yeah. All right, guys. So what do we got now? So y minus what? -2 equals m times x minus what? 1. Y piece, y piece. X piece, x piece. Slope, slope. So we can stop right here. We don't have to solve for y, because they didn't say to put it into slope-intercept form, like this one does. Aw, scheisse. So this one has a slope of 4, and it goes through this point. What would it look like? Y minus -3 equals m
4.
times x minus
2.
-2. Just for the interest of space, gonna do this. That becomes a plus, that becomes a plus. Yay! Right, the two negatives kill each other. So you get y plus 3 equals 4x plus 8. Subtract 3, I get y equals 4x plus 5. That's for number 2. Wow. Got blood over there. I like how the x's and y's on this one got really overexcited. So are we cool with that one? I mean, that problem was just like this problem. This one just wanted to go further, and this is what I normally want us to do, is to take it down to the best form. Okay, now, what about this one? If they give it to me like this, they gave me all the same information this one did. And what two things do I need? Point, slope. How many points do I have? 2 main ones, right? So you pick the one you like best. It doesn't matter. You pick the one you like best. You pick the one. Which one do you want to use?
-2, -4, 2.
Sure. -4, 2. If you use this one, you're going to end up with the same equation. Because there's an infinite number of points. It doesn't matter which one you use, it should come out to the same equation. And what's my slope?
3/8.
And it goes up, 1, 2, 3, and it goes over
8.
4, 8. Yummy. That'll never stop being creepy when you do it. Yeah, I'm going to take this out of the way for a minute. We'll do that in the process here. So now you should be able to set up this equation, y minus 2, the y piece, equals m times x minus -4. So that becomes plus. Is that cool? I'm going to try to sneak that shortcut in. Minus the negative is plus, might as well write it like that from the beginning. And now it's really good. Y minus 2 equals 3/8 x. What happens here when you distribute?
Cancel. 3/2.
Yeah. Right, the 8 and the 4 reduces to 1/2. You guys with me? And then I just have to add 2. So that'll be 4/2 plus 3/2 is 7/2. Oh my God, Jeff. Real quick, just to point something out. 7 halves. What is that better known as? What is that as a mixed number? 7 halves. 3.5. Is that cool? Because 7 halves is 6 halves and a half. 6 halves is 3.5. 3.5. Bam. Where does it look like? So that should, whatever number is here should be the what? The y piece of the
Line?
this. What form is this in? Y equals mx plus b. So what is this?
B.
It's the b. It's the y-intercept y value, right? What is the y-intercept of the line? Look. Where is it? What point is that? 2, 3, 3.5.
Yeah.
Holy shit. No, maybe.
Yeah.
So when this number is kind of grosser, that just means it goes through the y-axis at some freaky point, right? Lines can go wherever they want to. So I mean, I'm going to get someone with gross y-intercept. Did it really affect me up here? Not really, because I was using nice points that went through, not the y-intercept. That's a little bit freaky. Okay, hopefully that made some sense. It's always my hope. Okay. Let me see. Oh my God. Let's get at it. That's plenty. Today's a short day. We're basically out of time.